All right, so for an ellipse, we're going to have lots of little things here. Yeah, let me try drawing a new one. That wasn't very good. Let's see, we'll go like this maybe. All right, that one's a little better. Still not very good, but it's a little better. All right, so that's an ellipse. For an ellipse, we have lots of important things. First off, we have this point right here. And that point's called center. That's the center. Vertex. Oh, no, it has vertex though, too. All right, so this point, the center, is usually labeled as H and K. Then we have two vertex. What's the plural of vertex? Vertices. Vertices. These points right here, this point and this point, are called the vertices. The distance from the center to the vertex is called A. So if I were to draw the line from one vertex all the way to the other vertex, how long would it be? 2A. And that's called the major axis. The line that connects one vertex to the other vertex is called the major axis. These 2 points out here are called vertices. These 2 points up here are called co-vertices. And the distance from the center to a co-vertex is typically called B. So 2A is the length of the major axis. 2B, we would say, is the length of the minor axis, correct. So major axis is the long one, minor axis is the short one. AXIS, correct, major axis. Finally, somewhere in the middle of this ellipse, we have 2 points. This one, they would be right about here and right about here, and they're called the foci. Somewhere there in the middle. The distance from the center to a focus is called C. All right, so we have lots of letters there. We have H and K, which gives us the center. We have A, which is center to vertex. We have B, which is center to co-vertex. And finally, we have C, which is center to focus. All right, and then here's what the equation looks like. And I'm just going to give it to you. I'm not going to derive it. They figure it out. They derive it in the book if you really want to read it. The equation of the ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And then it turns out there's a formula that puts A, B, and C together. The formula is c squared equals a squared minus b squared. So it's almost your regular old Pythagorean theorem, but not quite. What's different about it? Got a minus in the back. All right. So that's all the information for an ellipse that is long, but not very tall. It's different for an ellipse which is tall, but not very long. All right, but not a lot different. That's the good news. All right, so now I'm going to try to draw an ellipse which is tall, but not very long. So it looks like this, perhaps. Oh, that one looks pretty good, actually. proud of that one. All right, so we still have the center. That doesn't change. Center, H, comma, K. Where's the vertex? All right, a better question would be, where are the vertices? No. The vertices this time are up and down because it's tall. The vertices are always going to be the longest. Yes, excellent. So here are the vertices. The distance from the center to a vertex is still called A. So we still call that distance A. A is always the distance from center to vertex. And then what would you call this point over here? These 2 points would be co-vertices. What do we call the distance from the center to a co-vertex? We still call that B, correct. And once again, we have the foci, about here and here. And once again, we'll see distance from the center to a focus called C. All right, so the only thing that really changes in the equation is this. We have x minus h squared over b squared plus y minus k squared over a squared equals 1. So what's really the only thing that changed? The denominators. And so how do you tell, if I give you an equation, how do you tell if the ellipse is long but not very tall versus tall but not very wide? And A is always the bigger of the two numbers. So if the big number is under the x's, the ellipse is long and not very tall. If the big number is under the y, the ellipse is tall but not very wide. We still have the same formula works. C squared is a squared minus b squared. And then there's one more number that we talk about, and that's called eccentricity. Yes, the eccentricity of the ellipse is C over A. All right, so what does that tell us would be a better question. Well, first off, do you agree that C over A always has to be a positive number? No, why not? A can't be negative. A is a distance. A is a distance from there to there. And C is a distance too, isn't it? So A and C are both positive numbers. Okay, so this is going to be a positive answer. But C is smaller than A. How come C is smaller than A? Because A is that length. C is always this length. So this number always has to be positive. But A is always bigger than C, so what else does that tell you if A is bigger than C? It's always going to be less than 1. So the eccentricity is always a number between 0 and 1. What happens if this C number is close to 0? Well, C squared is computed as a squared minus b squared. So if C is close to 0, that means A and B have to be close to each other. So if A and B are close to each other, what does the ellipse look like? It looks very much like a circle. So if the A distance and the B distance are almost the same, then the ellipse looks like a circle. So when the eccentricity is close to 0, that tells you your ellipse looks very much like a circle. On the other hand, what happens when eccentricity is close to 1? Then A had to be quite a bit bigger than B. So if A is quite a bit bigger than B, you get ellipses that look like the ones that I've drawn. They don't look very much like a circle at all. So, yes. So if this is closer to 1, then what's happening is the ellipse is getting extremely tall and extremely skinny. So you're right, it's looking more and more like a line. If C were exactly 1, that's impossible, but if C were exactly 1, it would be just a straight line. And if C were exactly 0, it would be a perfect circle. So that's what the eccentricity tells us. You can take a look at the eccentricity, and it gives you an idea of if the eccentricity is close to 0, you got something that's close to a circle. If the eccentricity is close to 1, you have something that's not close to a circle, it's closer to a line. So that's what that number tells us. It gives us an idea of how circular the picture is. Alright, so we're going to determine the center, the foci, the vertices, the co-vertices, and eccentricity of each of the following, and then we're going to sketch a rough graph. Alright, so we'll start with the graph. X squared over 25 plus y squared over 16 equals 1. Where's the center? 0, 0. Why is the center 0, 0? Because there's no x minus a number, there's no y minus a number. So center, that's easy enough, 0, 0. Is this ellipse long but not very tall? Or is it tall but not very wide? How do you know it's long but not very tall? The bigger number is under the x. Okay. What's the a number? 5, because this has a squared on bottom. So a is 5. What's the b number? 4. Okay. What does a tell me again? The length of what? Okay. So if I start at 0, 0, I'm going to go 5 to the right and 5 to the left. And what are those 2 points? Those would be my vertices. My vertices are negative 5, 0, and 5, 0. So I'll write that down here. Vertices. I'm going to just write it as plus or minus 5, comma 0. Okay, what's the b number tell me? My co-vertices. So again, I start at my center, which happens to be the origin. I would go up 4 and down 4. So I would have 0, comma 4 and 0, comma negative 4. There's my co-vertices. 0, comma plus or minus 4. Alright, so I can draw a picture now. So there's my ellipse. Alright, what haven't I found yet? I got to find the foci and the eccentricity. To find the foci, what do I need? I need the C number. Because C gives me the distance from the center to the foci. So the foci are going to be there and there somewhere. So I need that length C. And we have a formula for that. What's the formula for C? C squared equals a squared minus b squared. So that's 25 minus 16, which is 9. So C is 3. So where are the foci? Plus or minus 3, comma 0. Excellent. And finally, what would the eccentricity be? It's C over A, so it would be 3/5. Questions on that? All right, B then. Same thing, we're going to find the center, vertices, co-vertices, foci, and the eccentricity. Center? 0, 0, nothing's changed. 0, 0. Long but not very tall, or tall and not very wide? Tall and not very wide, and again, you know that because the bigger number's under the y this time. Okay. Where are the vertices? 0, 8, and 0, negative 8, because the a number is now 64. I'm sorry, a squared is 64, so a is 8. A is always the bigger of the two numbers. So we have 0, 8, and 0, negative 0, comma, plus or minus 8. Covertices. Plus or minus 3, comma 0, because b is the number 3. B is the number b squared there, so this is there and there. 3, comma 0, 3, comma 0. And that's not the best reflex I've ever drawn, but close enough. This is a rough graph. It's pretty rough. Foci. 64 minus 9. How much is 64 minus 9? 55. So C is the square root of 55. C quite often does not come out to be a nice number. C quite often has square roots in it like that. So where are the foci? About 7.4. Is that the x number or the y number? That's the y number, because our foci are straight up and straight down. So our foci are 0, comma, plus and minus square root of 55. And square root of 55 is a little bit bigger than 7, because 7 squared would be 49. Okay. And finally, the eccentricity. Square root of 55 over 8. It's always over the a number. A is 8. Questions on that? All right. What's different about C? We have a different center. All right. Where's our center? 1, comma, negative 2. So 1, negative 2 is right about there. Okay. Vertices. Are our vertices going to go left and right, or are our vertices going to go up and down? And again, how do you know the vertices go up and down? The bigger numbers under y. So A is 3. So where are the vertices?
0.
No?
Oh, sorry. 1.
All right, you're getting closer. We would start at the center.
2 separate.
We need two separate ones. We would start at the center, and we would go up 3. So if I start at the center and go up 3, where am I? 1, comma 1. And then I would have to start at the center and go down 3. 1, comma, negative 5. Yeah, so you're going to kind of have to write this as two separate answers. 1, comma 1, and 1, comma, negative 5. Covertices. What's the B number? B number is 2. So this time I need to start at the center and go 2 to the right. So where's that put me? 3, comma, negative 2. And then I need to start at the center and go 2 to the left, which is negative 1, negative 2. So again, for me, drawing the picture helps a ton for me. So I can see if I'm moving right or left, is X changing or is Y changing. I've seen people do it without drawing the picture. For me, I like the picture. So I had negative 1, negative 2, and I had 3, negative 2. Alright, so here's my ellipse-ish kind of graph. Sort of. Alright, then we're going to find the C number. C squared is 9 minus 4, which is 5, so C is the square root of 5. Alright, so where are the foci? A little over 2 from the center. Which way? Up, down, left, right? One's up, one's down. So I would write these this way. If I'm changing up and down, which letter's changing, X or Y? Y. So the X is going to be 1. And then I would write it as -2 plus or minus square root of 5. You could write 1 comma -2 plus the square root of 5, and then another one 1 comma -2 minus the square root of 5. I prefer to just write it as one answer like that. Well, it's really 2 answers, so it's plus or minus. And finally, my eccentricity.